All right, so 9.3, we're getting into a specific case of right triangle. So it's going to be a right triangle with an altitude in it, and I'll show you what that looks like in a second. But it's one very specific case that we're going to deal a bunch with today. The first thing that we're going to do, we are going back into similarity a little bit, just for this one theorem. It's a right triangle similarity theorem. A right triangle similarity theorem. And I know I didn't have you copy anything down. So what I would like you to copy down out of this, I want you to draw the picture. Okay, I want you to draw this triangle. Okay, and I want you to write this down. Okay, you don't need to write the words, just the picture and then the similarity statements. Let's copy that down. I'll give you a couple minutes and then we'll talk all about it. All right, so that picture that you drew, that is the situation that we're talking about today. Okay, it's a big right angle, right triangle, with an altitude coming out of the right angle. Okay, right triangle, altitude coming from the right angle to the hypotenuse. And altitude, remember, is perpendicular from the vertex to the opposite side. So that's our situation. And what that does is it creates three similar triangles. Three similar triangles, including the big one. So the big triangle is one, and then you see your two smaller ones here. You see the smallest one, and then the medium-sized one here. So we are creating those three similar triangles. One thing that they're going to ask you to do is simply to write a similarity statement comparing all three of those triangles. Okay, so triangle something is similar to triangle something is similar to triangle something. Now the trick here is we got to make sure that we've got everything lined up. Everything needs to match up. Okay. So here's what we're going to do. Okay. We're going to start with one of the triangles. Okay. It doesn't matter which one we start with. I'm going to start with ACD. I'm going to start with that one just because it's the leftmost. Doesn't matter. I'm going to call that ACD. Now we're going to match up. I'm going to ignore the fact that we already have these here. Okay. I'm going to walk you through on how we can do this when we don't have those similarity statements. So I'm going to say ACD. Okay. The next triangle that I'm going to deal with, I'm going to deal with the big triangle. Okay. The whole big ABC or whatever. But we got to match up those letters. So I've got A, C, and B, those big ones. They've got to match up to the angles of A, C, D, that smaller triangle. Okay, angle A is going to be the exact same, right? Whether it's the angle A for the big triangle or the smaller triangle, angle A is angle A. So A needs to match up with A. It needs to be in that first spot. Okay, if I look at C C, when I look at this figure, right, the smaller one, C is not the right angle. Which means this angle right here needs to match up with not the right angle over here. It needs to match up with B. So that's going to be a B. And then D is my right angle here. In my big triangle, C is my right angle. We call that ABC. And we got to do the same thing with that last one. I want you to go ahead and do that small triangle. See how it's going to match up with the other one. With that D, C, and B. Talk to somebody about it. What do you think that third triangle is going to look like? All right, what do we think that third one is going to look like here? Haley? It is going to be C, D, D. Okay, C in this case being the smallest angle, B being the next, and then D being our right angle. Okay, so we can go through and look at each triangle individually, try to match up those angles, right? I'm going to show you kind of a shortcut here on how to make sure that we've got the right thing. Okay, angle A is always going to be angle A, right? So angle A needs to match up. Wherever I see my two A's, they need to match up. Wherever I see my B's, they need to match up because B is always going to be B. Okay, angle D, if I have angles at this point right here, they're both right angles. So D has to match up because D is always going to be a right angle. So D matches up. There's always going to be one letter that moves throughout your statement. Okay, and in this case, it's C. Here it's in the middle, here it's at the end, here it's at the beginning. Okay, this angle, that big right angle, that's the one that's going to move in every triangle. Right, that's the one that's going to be in a different location every single time. All the other letters are going to stay in the same spot. A was always in the first position, B was always in the second, D was always in the third. C moves. And C is that one is the only one that shows up in all three triangles. So we know that's the one that's going to move. Okay. So when we do this, and you will be asked to do this on the quiz, you have to be able to create the similarity statement. When I check it, that's what I'm checking for. Is the A in the same spot, the D in the same spot, B in the same spot, the C in different spots every time. Okay, any questions on that? By creating that similarity statement, that's going to allow us to set up proportions and solve some problems today. By knowing that these are similar figures, we can set up that proportion. Okay. All right, before we do that, I want you to do what we just did, but with this figure. Okay, create that similarity statement between the three triangles for this RUST figure. you're stuck, you're not sure what to do, start with one triangle. Just name one triangle however you want it. Go to the next and make sure those letters match up where they're supposed to match up. And move when they're supposed to move. Talk to somebody about it. See if there's words, see if yours make sense.
Oh, I thought you said R something different.
All right, I want you to look at yours. Okay. The two spots where you have R, are they in the same location? Okay. The S, are they in the same location? U in the same location. T, does that move? Once in the first, once in the middle, once in the last. Good. That's what I'm going to check. That's what you check. That means we're good. Okay, if all those things hold true. Okay.
Does it matter like what order you do like the triangle, if it goes last, middle, first?
Nope, doesn't matter. Does not matter at all. All right, moving on. So now we're going to take that idea, the fact that they are similar, to be able to solve for a variable here. Okay, and this can be kind of tricky because we got a lot of things going on. First of all, it's a 3, 4, 5 triangle. That doesn't necessarily help us, but I just wanted to point it out. We're trying to solve for x here. You got to think of two of your triangles and set them up as similar figures. One triangle that you're going to use is the big triangle because we know all three sides of the big triangle. And then you can either think of it as using the medium-sized triangle, right? Or if you want to try using this triangle, that works as well. But we need to be able to set up a proportion that's going to work there. Now I'm going to show you one way that we can do this. Okay. One way that we're going to, if you want to memorize it, I guess, is going to make it so that it's going to work every time. So you know what sides are going to go over. Otherwise, we're sitting there, we're thinking about how to match this up and the similar figures and all that, and it takes a little bit of time. Here's what we can do. Okay, I'm going to show you. This is x over 4 is equal to 3 over 5. Okay, this is the proportion that we can set up. So it's always going to be your altitude. Okay, the altitude is the line through the middle. It's going to be the altitude over the longer leg. Is equal to the shorter leg over the hypotenuse. And this setup is going to work every single time. Altitude over the longer leg is equal to the shorter leg over the hypotenuse. I'm going to show you why it works, right? Because I don't just want you to memorize something. I want you to have a vague understanding, at least, of why it's going to work. I am looking at the medium triangle and the big triangle. Okay, x for the medium triangle, x is the longer leg. Hold on. X is the shorter leg. X is the shorter leg of the medium triangle. And 4 is the hypotenuse of that triangle. So really, for that red triangle that I have here, this is shorter leg over hypotenuse. And then for the big triangle, I have shorter leg over hypotenuse. Okay, that's why it works here. Shorter leg over hypotenuse, shorter leg over hypotenuse. But if we remember these four things here, it's going to work every single time. I will tell you, this is probably traditionally the most confusing problem that you guys see here. Is people forget how to do this. Because we're gonna look at some theorems and we're gonna do other things where we're calculating for x a different way in a different situation. You come back to this, you gotta remember altitude over longer leg, shorter leg over hypotenuse. Okay, good?
Could you do the hypotenuse over hypotenuse and then shorter leg over shorter leg?
Yeah, you can do that as long as you're staying consistent with it. Yeah, because and if you do that correctly, then your cross multiplying is still going to be 4 times 3 and 5 times x. Yeah, perfectly okay. However works for you. All right, so we don't even need to solve. I just want you to set up a proportion that's going to work here. Set up a proportion that's going to work for this one. Okay, check somebody, see if their proportion is going to work here. All right, here we go. Raise your hand and tell me what proportion do you have here, Weston?
X over 12 is equal to 5 over 13.
Okay. Anybody have anything different here? Yeah.
12 over 13 is equal to X over 12.
Okay. Anybody have anything different? Still works, right? Cross multiply, you still have 13x is equal to 12 times 5. So either one of those is going to work. Okay. Yeah, that's right. Good. Let's move on. Next thing that we're talking about is the idea of a geometric mean. Geometric mean. Mean is another word for average, right? We've used that word mean before. But now we're talking geometric mean, and geometric mean is different. Regular average is add two numbers together, divide by 2, right? Geometric mean, you're going to multiply the numbers together and then take the square root. Okay, so geometric mean, you're going to multiply the numbers together and take the square root. If you want to write that down, right? The geometric mean of a times b is the square root of a b. Multiply them together, take the square root. That's going to be the geometric mean. Multiply them together, take the square root. So if I want the geometric mean of 4 and 9, what's the geometric mean of 4 and 9 going to be here? Right? 6. 4 times 9 is 36. Take the square root, we get 6. Okay? That's geometric mean. Sometimes it's going to be a perfect square, sometimes it isn't. And if it's not, then it's simplest radical form. Okay, I told you heading into this chapter, we're going to use simplest radical form a lot. And we're seeing that. Okay, multiply them together, take the square root. That is the idea of geometric mean. You will see some problems that simply say, find the geometric mean of these two numbers. Multiply them together, take the square root, simplest radical form if we need. But then we're going to use that when we start talking about a new situation. And it's still the same picture, still the same idea in terms of the picture. And there are theorems that are in the book based off of this. I think they're too wordy. I think there's just way too much. That's why I didn't have you copy them down necessarily. If you did, that's fine. But there's a lot of words to it. I think sometimes it's easier just to see something like this. All right, so we've got that same situation. But now what they're going to do is they're going to give us, they're going to call this, let's call this X, Y, Z, A, and B. I want you to copy down that. For sake of it, we're going to call this whole thing C. So let's copy that down, because that's going to help us with the next three things that we're looking at. And I'm going to give you three equations here. Okay, three equations. I'll kind of explain what they are, and then we're going to apply them to these situations. Okay, one equation and it's basically the same thing that they're saying down here, just with just using the letters instead of the names. One equation deals with the altitude. Okay, and this is going to be the altitude squared is equal to y times z. So x squared is equal to y times z. So that altitude squared is equal to this part of the hypotenuse times this part of the hypotenuse. And in this situation, they're going to give us the two parts of the hypotenuse, this length and this length. So x squared is equal to y times z. Okay, that's for the altitude. The other ones are very similar to each other. They're talking about the legs of the big triangle. So the next one is going to be a squared. So the leg squared is going to be equal to y, so the portion of the hypotenuse closest to it, times c, which is the whole hypotenuse. A squared is equal to y times c. And then it's the same thing for the other leg. B squared, right? So now it's this leg of the hypotenuse. B squared is equal to this portion, so z times the whole thing. Z times c. So this diagram, this picture, along with those three equations, are going to help us to solve most of the problems that we're going to see. So make sure that we have those down correctly. Okay. Because they're not on the orange sheet. This is something that you need to know. Okay. And I don't want you to get so caught up. Once we get going, I don't want you to get so caught up in what's this letter, right? Because they might ask you to solve for x in the problem, but x in the problem might actually be this part right here. Okay. So this is just our general form that we're talking about. You need to understand how this works. The altitude squared is equal to the two parts of the hypotenuse multiplied together. The leg squared is equal to the part times the whole thing. Okay, so using the letters helps us to visualize it, but it's not going to help us memorize exactly what to do. So let's take a look at this. And really, what we're doing is we're finding the geometric mean of two numbers. Right, if you're solving for x here, you're multiplying y times z together and then taking the square root. That's where the geometric mean comes in. We just don't call it that necessarily in this problem. Okay, so we're solving for the altitude here. And we said x squared is equal to what times what? In this case. 6 times 3, right? So we're looking at x squared is equal to 6 times 3. So x squared is equal to 18, and we got a simplest radical form. And then I want you to go ahead and solve the other one as well. Okay, look at your notes, see what you need to set up. Simplest radical form for it. Let's throw a couple more in there, and then we'll be good. Throw for those two as well. X is going to be 3 root 2 there. Why don't you talk to somebody about y, a, and b for that other triangle, please?
For B, that would take 5.
All right, hey, remember when you are finding the leg squared is going to be equal to the part times the whole hypotenuse. So 2 times 7 there. When we do that, we're going to end up with the square root of 14 for that one. For a squared, it is just 2 times 5. So the square root of 10, can't do anything with that. And then b squared is going to be 5 times 7, which is just the square root of 35. Again, can't do anything with that. That is simplest radical form right there. For the, right there.
On the test, if you can't do anything with the square root answer, would you want us to round it or keep it?
Nope, keep it like that. Unless it specifically says to round, then we're leaving it like that. Yeah. Right, any other questions about it? Okay, one more just because it's slightly different and because it's a great real world situation picture. I mean, look at this guy. This guy is measuring the height of the gym by holding a cardboard box in front of his face. Interesting. I mean, you can't make this stuff up. I mean, you obviously can't make this stuff up. Okay, so I know it's a little hard to see, but this guy's holding a cardboard square in front of his face. Here's the triangle. Right, 8.55, this is W. We want to find the height of the gym wall. Okay, so you're still using that equation, one of those equations, we're just not solving for the squared thing anymore. Okay, talk to somebody, figure it out, talk it through together, please. Figure out what the height of the wall is going to be.
I squared 8.5. Made it equal to 5W. I solved it out. And then I had to write out W.
All right. So we're still using that altitude one, right? Because we know the altitude and we're talking about the two parts of the hypotenuse. So it's 8.5 squared is equal to 5 times W. We solve that out, we get W is equal to, I believe, 14.45. But is that our answer? No, because we want the height of the entire gym wall, not just from this guy's eyes up, right? We got to take into account the 5 feet that's still down there. So we got to add that 5 on. We're looking at 19.45 feet. That's going to be our answer. Okay. When you see this problem, I'm going to warn you right now. When you see this problem on the quiz, and maybe it's the test, I don't know if it's one of them, maybe it's both. Don't forget to add that on. Okay. People are going to forget to add that on this problem, and you're going to get it wrong because you've got to add it on. Okay. Don't forget about that bottom part. All right. Go ahead.